Hey boys and girls, today we are starting fractions. So we've been talking about fractions a lot when we've been talking about division because we've said over and over again, a fraction is a division problem. So we've seen that as we've been dividing, especially as we've been dividing decimals, but we've been saying a fraction is a division problem since we started school. So today we get to start with fractions. All right, so in your packets, I gave everybody a piece of cardstock that looks like this. These are your fraction strips. So this is your hands-on materials that you can use to help you as we begin adding and subtracting fractions. Now when you're here in the classroom, I have some fraction tiles that I can give you to use while you're here, but this is the same exact thing. And I was able to get us some cardstock so that they'll last a lot longer. So the first thing we're going to do is color each strip a different color. So your whole needs to be one color. And then what is this representing? These two parts, they're each going to represent 1/2. Then you have these three, so this one thing is put into 3 equal parts, so make it a color. This is showing 4ths because I see 4 equal parts. Here's my whole. You can always look and compare that way. These are 6ths. It's fun to say, 6ths and 8ths. All right, so I'm going to show you guys mine, and I know you can see a little bit of my computer, but that's all right. Okay, so once you color them, you can cut them out and then put them somewhere safe, like a Ziploc bag. So stick them all in a Ziploc bag when you're done using them. I think I've already lost one, it looks like. That's not good. So I'm gonna put these all right here so we can see them. And I've lost my 1/2. Oh goodness. Okay. We'll make it work for now. It's around here somewhere. Okay, see, it's important to not be like me and not lose them. All right, so it doesn't matter what colors you do, whatever colors make you happy, do those. I think I'm gonna turn this way so you guys can see it better. Yeah, let's do that. Okie dokie. All right. Now this is gonna help be your visual as you are completing some of your problems. Now, as you can tell, we don't have one for every fraction that you're going to come across, but that's okay. We can use this to help us. Just like we don't have 7ths here, but I can look at my 6ths and my 8ths, and I can get an idea of how 7ths would look. Okay, so let's just talk about fractions for a minute and what a fraction is. We've said a lot that a fraction is a division problem. And you're actually saying it when you've got it there. Just like here, this is one thing divided into 6 parts. That's what 6ths are. Okay, we also have our 4ths, and that's one thing split into 4 parts. Okay, so let's just look at one of these at a time. So I love to have the one whole. This is our, this is our benchmark. This is what we look at. We can see how something compares to a whole. Now remember, we've talked about decimals a lot. They're a part of something. They're a piece of it. They're a fraction. Fractions and decimals are the same thing. They're just shown in a different way. So remember that when we're talking about a fraction, just a plain old fraction, we're talking about something less than 1, which would be like a decimal, right? We have said already that the decimal, I can put me in here a little bit, that the decimal the fraction 1/2 is like the decimal 5/10 or 50/100, because we know, and we use money a lot, if we have $1, half of $1 is 50 cents. 50 cents is like saying 50/100 because you have 50 out of 100. All right, same with fourths. I can think of fourths and money. There are 4 quarters in $1, 25, 50, 75, $1. So if I had 3/4, I know that's the same as 75/100, 75 out of that 100. All right, so let's keep comparing how they look when we put them here. So here's our whole, our half, our third, our fourth. Remember, we don't have any fifths, our sixth, and our eighth. Okay, so one thing that you're noticing is that as our fraction, when we look at our numerator, our number that's on top, our number that's being divided really, and our denominator, how many parts it's being put into, as our denominator gets larger, our pieces, or our amount, or our value, is actually smaller, which is a little backwards from how we normally think of numbers, but that's okay. Let's think about if you had a pizza, one pizza, and you were going to share it with your brother or your sister or your friend, one other person. I have one thing, I'm dividing it in 2 parts. Me and my friend are going to share that pizza. So we each get a part. We're getting a pretty big amount of pizza, okay? Well, your mom says you have to now share with another person. Or maybe mom says, hey, how about me? So you, your friend, and your mom. So now you were getting half of that pizza. Now you're getting a third. You're getting less because you're dividing it into more parts. So yes, our denominator got larger, which means we're dividing it into more parts. So that's why it's actually a smaller amount. So a lot of times when we get pizzas, they're split into eighths. 8 slices is how pizza comes a lot. So if it's you and 7 friends and y'all are having to share it, man, you're getting a lot less than you could have if it was just you and your one friend. Always use this though to kind of help you, okay? So another thing that I want you to do with these is flip them over and put your initials on the back. You might even want to put all 3 of your initials just because somebody might have the same first and last initial as you. That way, when we are here at school, or if you're at home, and I know a lot of y'all have siblings at home, and they get misplaced, you'll know which one is yours. And so if you happen to drop them here in class, we can do that. So that's another thing you can do to keep up with them. So let's start playing with these. So as we're adding fractions, we can sometimes use a model if we have a model to use. So I'm going to write a fraction on my board, or I'm going to write an addition problem. So let's say I have 1/2 plus 3/8. Okay? So I've already got my half up here. I'm going to scoot it this way a little bit. And I'm adding 3/8. So grab your eighths and do this along with me. And I'm going to, you know, when I'm adding, I know I'm putting my amounts together. So let's say I was eating a half of pepperoni pizza, and then I wanted 3/8 of the sausage pizza. So let's look at this. Could we say that we almost ate a whole pizza? It sure does look like we almost did, doesn't it? Almost filled up the whole thing, but it is not quite a whole. It's still less than 1. All right, so wonder what the answer would be. I know that it makes sense as I'm looking here at my model that my answer is less than 1. Okay, so let's try some things. All right, well, we're adding, so probably you would say 1 plus 3 is 4, and 2 plus 8 is 10. Now let's think about what we know about 4/10. Let's see if this answer makes sense. 4/10. Now I don't have tenths, but let's draw some here. So here's my whole, and I'm going to put it into 10 parts. So if I'm trying to do about half, I know that's here because that helps me. And I know half of 10 is what? Half of 10 would be 5. Now these might not be perfect. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so there's 10 parts. They're not perfectly, but so let's see what 4/10 looks like. 1, 2, 3, 4. Would 4/10 make sense as my answer here? Probably not, or definitely not, really, because look at what 1/2 plus 3/8 is. It's almost a whole. 4/10, that's not even half. 5/10 would be half. This is not even half. This does not make sense. This cannot be my answer. That's not close to 1 whole. Okay, so when we're adding fractions, we can't just say add our numerators and add our denominators. And the reason we can't do that is because in this case, halves are not the same as eighths. And we can see that very clearly here. Halves are not the same as eighths. I mean, they look nothing like eighths, do they? I'm going to erase our tenths here. So we know that answer is not right. Okay. You know, when we're adding things normally, when we say you have 5 eggs and I give you 3 more eggs, we have 8 eggs. You had eggs and you put the eggs together, all right? But when we're looking here at this problem, we can't just add together like we did those eggs. These are halves, these are eighths. You can't just stick them together like they're the same thing because they're not the same thing. An eighth is not the same thing as a half. All right, I think about it like this. They are both fractions. We can agree that they're a fraction, but they're different. So like cats and dogs. Let's pretend that I have 2 cats and 8 dogs. You would say I have 10 what if I said I have 8 cats and 2 dogs? You could say I have 10 pets, 10 animals, but you would not say you have 10 cat dogs, right? Because they're not the same. You would not just mash them together like they were. Or you wouldn't say I have 8 cats and 2 dogs and I have 10 cats, because they're not. Okay, do you see what I'm saying? We would say 8 cats, 2 dogs, you have 10 pets. We chose something that they both have in common that does show that. So that's what we have to do with fractions. So I'm going to put you down back here. We have halves and eighths. Like I said, we can't have our cat dogs. We can't just stick them together like they're one thing. We tried to do that, and that did not work out right, did it? That gave us 4/10, made no sense. We saw it here on our picture. So, just like I said, when we have cats and dogs, we have to put them together as pets. When we have halves and eighths, we have to see what do they have in common. All right, so think about halves. Let's think about that first. When we've got our eighths here, how many eighths do you think it would take to make 1/2? Now remember, a fraction is a division problem. What's half of 8? Half of 8 would be 4. Okay, let's see how my eighths fit in right here. 1, 2, 3, 4. That fits perfectly. So I can say that 1/2 is equivalent to 4/8. Now, I would not say that 1/2 is the same as 4/8 because they look very different, but they do have the same value. When you put 4/8 with 1/2, they are the same value, but they are definitely not the same thing. Just like cats and dogs aren't the same thing, but they are both pets. So, in order to add my halves and eighths, I can see here that they do have eighths in common. So if it takes 4/8 to equal 1/2, and remember I had 1, 2, 3/8, didn't I? 1/2 and 3/8. Now I could put them all together as eighths because you figured out that 1/2 is the same value as 4/8. So 4/8 plus 3/8, those are the same things. They're all eighths. Now I can add and say, yep, I have 7/8. 7/8 makes sense because 7/8 is really close to 1. Okay? So hopefully that makes some sense to you. And let's try and do another one. So I'm going to erase this. I'm going to keep my 1 whole here because it's very helpful to me. Okay, let's do, let's do 1/3 or 2/3. Trying to think of one that I can use here with my examples. How about 1/3 and 2/6? 1/3 plus 2/6. I'm gonna write that down. 1/3, because I have 1/6 and 1/6, so that's 2/6. Remember, this wouldn't be 2/12. That doesn't make sense. Let's think about 12ths. If I keep on getting smaller, 12ths are going to be way smaller than 8ths. That wouldn't make sense. Okay? Again, a common misconception I see is just, oh, 1 plus 2 is 3, 3 plus 6 is 9, 3/9. Let's think about ninths. 3/9 is technically the same thing as 1/3. Because 3 divided by 3 is 1 and 9 divided by 3 is 3. And 3/9 is still the same value as 1/3. Or we could look at it and say, here's 1/3. If I had ninths, they would look like this. 3/9 is the same value as 1/3. That wouldn't make sense. Okay? So remember what we said. When we have our 1/3 plus our 1/6, we can't just mash them together. Not a cat dog. We have to do something that puts them in common, something that you can say they both are. So then we look again and we try and say what is equivalent. What can I use for all of these? So, you know, try it out with your fraction tiles. My eighths, that's not going to work quite right. See how they're not exactly equivalent? And really they're not going to work right here with my 6th either, so it's not 8. Nope. Okay. You might look at the numbers and it helps you decide. Let's look at our half and see how it looks towards it. Yeah. Now I do notice something here. Here's my half. I notice that 1/6 fits there. A half, I wonder how many 6 would be in a half. Well, let's try it. So we're going to cover up our stuff, and that's okay. 1/6, 2/6, 3/6 fits perfectly. 3/6, that makes sense because 1/2 and 3/6 have the same value. Because, look at it, they're the same amount. And 3 is half of 6, right? 1 is half of 2. This is showing that. So, I can use my 1/6 here with these two. And I know that 1/3, let me see, 2/6 are going to fit on my 1/3. Let me rewrite it. So I can rewrite 1/3 as 2/6. Then I've got 2/6 equals 4/6. That's the same value. Yes, 2/6 and 2/6 is 4/6. Now I wonder if I could say it another way. So I know that 1/3 was the same as 2/6, the same value. So instead of 4/6, 1, 2, 3, 4, 6, I could also call it 1 2/3. 4/6 is equivalent to 2/3, or has the same value. And 4 divided by 2 is 2, and 6 divided by 2 is 3. So we can see that they're equivalent. We did the same thing to both digits. So there's another example. All right, so I just wanted to do a couple with y'all. I know this has been kind of long, but fractions is a big part of 5th grade, and I want to spend a day just kind of playing with fractions before we get into it. So make sure you cut your strips, label them, put them somewhere safe so you don't lose them. I think you're going to enjoy having that hands-on resource to help show you some of your answers.